All right, now we're going to cover AES. This is, hold on, I need to enable my content. Now we're going to cover AES. Now, I did not make these slides originally. Raymond Hache did. He made them as a capstone project for OSU. He needed something, so he actually researched it and made them, and then he did an amazing job. I have modified them slightly, but for the most part, they're his. Okay, so give him 99% of the credit. Okay, AES, based on the Richendale algorithm. Okay, from 2000, it became a standard in 2001. So the system that could break DES in 1 second would take 149 trillion years to break AES. What do you think? Is that good? Remember how DES was? It was pretty complicated. So it would take forever. Good performance of both hardware and software. Works on a wide range of environments. Variable block, variable key. What was the block size of DES? Anyone remember?
48.
No, 56.
Block size. Block size.
What was 200?
Block size of DES.
Oh, 2.
Block size of DES. Come on.
64.
64. Remember we broke it into 232s? The key was 56 bit. Okay. DES was stuck. Remember we talked about how DES actually initially had a larger block size, but they lowered the block size, and no one really knows why the NSA did that. All right. Variable block size, variable key length, variable number of cycles, and all that. Simplicity, low memory requirements, and sound design. In other words, people can look. It's not secret, where DES was secret. Okay.
What's secret?
What now? DES was initially secret. It's no longer. AES was never secret. AES is based on sound math. It was literally a public competition. Okay. Works for ATM, HCTV, ISDN, voice, satellite, works for everything. Very, very, very fast. Okay. Details of this is most use what's called a Feistel structure. In other words, some bits and intermediate steps are transposed. It was named after Horst Feistel, even though names aren't important, I guess. Okay. 3 distinct invertible uniform transformations or layers, which we will walk through all of them. The algorithm itself does byte sub, shift rows, mix columns, and add round key. We're going to walk through every one of these. Okay. So you will understand these by the time we're done, and we'll be good. Okay. It's resistant, not resistance. Oh well, to all known attacks. Speed, code compactness, wide range of platforms, everything make it good. Design simplicity, it's a very good design. Strong math, number of rounds, variable block size, so it's a really good algorithm. Okay. Now let's talk about hex first. Initially, up to I think last year when people took this test, did this homework assignment, I would give them a word, and they would work through that word for the entire assignment. So guess what happened if you mess up on step 1? Screwed up everything. So now it's changed where every step is different. So step 1, I give you a word, and you convert it to hex. And step 2, I give you the answer to start with. So in other words, you're not going to be using what you did for step 1. That way, if you messed it up, that way it doesn't bleed over into the next. Because literally, people mess up on step 1, and then you might as well give up at that point. Okay.
Only fix one mistake.
Exactly. So we have hex values. So we're going to change the word dog to hex. We take dog right here, 44. Okay. O, 6 right here. See the O? 6F. It even says, I think on the one I give you, says first letter, second letter. So first letter is at the top. So O, and then for G, it's 6, 7. Easy enough to do. So if I said the number 7, what is it in hex?
37.
37. That help? Maybe that help?
Yeah, I just couldn't.
Well, that's fine. Yeah, just tell me if you can't see it. I'm going to go, but I didn't think about it. Okay. So easily enough converting to hex. How about an S, a small s?
That is 733.
How about a big S?
That is 53.
Easy enough? So it is case sensitive, big to little, it does matter. Okay. Now we need a cipher key, and we're going to give you that. We're going to use this cipher key to create a round key out of it. Okay, so I'll be giving you the cipher key. So on the practice assignment, you'll see I give you the cipher key. What we do is we take the last column of the cipher key. Again, I give you the cipher key. You take that and you shift it up by 1. So the 22 goes to the top, the 61 goes up, and so on and so forth. So the 82, or 8A, I'm sorry, goes to the very bottom. Okay? Easy enough? That's the last column. Then we take that last column and run it through this S box, not X box. So 22, what do you think 22 will become?
No, wait, I can't see my arms.
Well, Taylor, I bet
So
can
is
see.
it
She
going
could
to
have-
93?
What do you think?
Would that be the 93?
93, exactly.
Okay.
So we take 22 and we get a 93. Raymond did a good job on animating these things. Let me tell you, it took forever. So that becomes 93. Then we take the 6 and the 1, and we get the EF. And that goes in position 2. Then the same with BE. He was like, can I just do one? No, do them all. Then the AA. It was hard to find words that didn't overlap letters, too. 7E. We had to reverse engineer it to get that. Okay. So far, so good. So we took the first column, the last column. What did we do with it?
We shifted up.
We shifted up by 1. So the 8A went to the bottom, everything else rotated up. Then we ran it through the S box and made this other thing. Okay? Now, we just made the 93 EF. You see it right there? So this is the first column of our cipher key. This is that column we just made.
Okay.
We're going to XOR them. Then we're going to XOR them again. Now let's see how to XOR them. Take 37, convert it to binary. I did not give you the chart on your homework, but hopefully you can handwrite one. Say print one out. No, handwrite one. Okay. So we take the 37. So how do we do this? You take a 3, which is 0011 right there, 0011. So 0111 should be a 7. It is. Everybody see that? XOR, one or the other, but not both. So what happens with 0 and 1? So what are we going to end up with? This position is a 1. How about this position? 1 or the other, but not both. 0. How about this one? 1. 0.
0, 1, 0, 0.
Okay, let's see if we're right. 1, 0, 1, 0, 0, 1, 0, 0. Exactly. Then we need to XOR it with 1. There we go. Okay? So that's the final result, and then we convert that to A5. How the heck did we get A5? Well, we have 1010, which happens to be A, and 0101, which happens to be 5. So this A5 goes right here. Everybody see that?
How did you get the 93 from 37? You said
37 was the first column of our cipher key, which I gave you. We created the 93 by taking the last column, rotating it, running through the S box, and that's how we got the 93.
Oh, okay.
Okay, so we made that one. See, after sub bytes, because we subbed it through the S box.
Where did the first column of recon come from?
I give you that.
Okay.
I give you Archon.
Recon.
Yeah, I give you Archon. Okay.
So to decode this, so far you need the S box and the cipher.
Oh, you need a lot more than that. You need a lot more than that. Which is all these steps. So let's walk through the next one together. Okay. I can't write it on the screen because I suck at writing. Actually, you know what? I'll do it on Notepad. Okay. So what do we got? We got. Actually, you know what? We already know that one's 66. Let's do the next one so we can't see the answer. We want to do 3F. Okay. What is 3F in decimal? On the binary, I'm sorry.
0, 0, 1, 1.
1, 1, 1, 1.
You got an extra zero. I mean, the one,
Nope. That'd be right.
is it? The 3? It's 0, 0, 0, 1. Oh,
No.
0, 0, 1, 1.
0. Okay. You're
Okay, then we got AE. What's A?
1, 0, 1, 0.
What's E?
1, 1, 1, 0.
Not 4, 4. He's testing.
Okay, let's XOR them together. What do we get?
0.
1, 0, 0, 1, 0, 0, 0, 1.
Okay. So that's our answer so far. Now we're going to XOR with 0, 0. So what do we get?
1, 0, 0.
So in other words, you see XORing with 0, just don't bother. It's the same thing.
Which is 91.
Okay, so that ends up being, so we got 1, 0, 0, 1, which is a 9, and a 1 is a 1. So 91. You all agree with that?
Yes.
So let's check and see if this block gets filled in with a 91. Ta-da! Is everybody okay on how to do this? Okay, we're not going to do the last one. We need a 12.
Whoa.
Okay.
91.
Seriously? No. Don't.
Yeah.
No, seriously. You're not asking that. We just
I
Did
know,
it
I know,
right
I
there.
just watched you.
We just did that. Because this is the 9. This is the 1. See?
Yeah, but I'm saying, where did you get the 1, 0,
Convert the
0, 1?
binary back to hex.
Oh, I convert this back to hex.
Binary.
1, 0, 0, 1.
This is binary. Convert to hex.
Where did you get that number? I'm saying.
We just made it. We just did it. This was 3F. This is AE. We XORed them together and got this.
So you're XORing the last two?
Yes.
Yeah, I XORed those two together and I got this last one. Okay.
All right.
You're just sitting in on this, okay? Calm down. You're like on well, you're literally on the last week of class, pretty much. And your first day here, so. Okay, so everybody okay on that? So, what that does, now that we have this, we just made this number. All that work was to get the first row of the round key. First column. So how are we going to get the second column? Well, let me show you. We're going to take column number 2, take column number 1, XOR them together, and get that. Can you do that part? Now let me show you this. I didn't show you this so far. If you're going to be handy dandy calculator right here, this will not work every time. I'm going to tell you right now. So 4A, let's go to hexadecimal. 4A, where's XOR? XOR, A5, EF. Okay?
And the reason it doesn't work all the time.
That's my question.
It won't work when we get to the matrix multiplication. I'll show you when.
But this it will work.
Okay, we'll do the second one. 12, XOR, see the little XOR button here? 66, 74.
Okay.
So it'll always work on this part at least.
It'll work for 99% of this stuff. Maybe 95% of this.
If you type
I'll show you where it won't work. I will show you where it won't work.
Okay.
But it's important you know how to do it. Because it won't work always. And if you think, yeah, I'll just get that part wrong. Well, maybe that's the one part that's on the test. So, okay. So, to get the second row, we are taking the second column plus the column we just made, XORing it. Oh, I got to click back in here. Okay, put that one back. We're going to put that guy back up. This guy. Okay, so the third column and the one we just made, XOR them. You okay so far?
Mm-hmm.
Put that guy back. Put that guy up there. Bring this guy over.
On the last column.
Bring the fourth column down. XOR those guys. Now you notice we only used that archon for one, didn't we? We only used that archon one time. Do not use the archon every time. Someone did last semester. I thought I had to use it every time. I'm like, well, don't. You only use the archon once. Okay? So then we put that one back, and then this 38 goes up there. I wanted him to bring it up diagonally, but that was way too much work. So far so good? There we go, we have our round key. That's step 2.
This is accessible, right?
Oh yeah, I mean, I even gave you the PowerPoints.
So
They're
next
animated.
time, forget, like, I can go back.
Yeah, make sure when you do this, if you want to look at the PowerPoints and you bring them up, don't just look at each slide, because this is one slide that has 20 steps on it. You have to play it, play the animation. Goes next.
What's R time?
It's just what's used in here, I don't know.
The Almighty,
Actually, I don't know what it stands for.
the Almighty can do it, isn't that?
I am not a mathematician. Funny thing is my brother is. I could have been one, but I didn't go toward math. I went toward computers, and then it's one of those things that, I aced calculus back in 92. I can spell it now, but that's about all. Okay. All right, so now we have our state, we have our cipher key, and our new state. You take our state, we XOR with our cipher key, and we get our new state. That's the next step. Very simple. And if you don't know how to do that, I'm going to show you again. So if I took 85, XOR 37, what do you think I get? B2. Easy enough?
So we have to do,
Every block. So if I took bottom right hand block, 06,
And BE,
XOR with what?
BE,
BE. What should I get?
B8.
B8.
Hey, what happens if you XOR B8 and like 7 E?
B8, XOR 7E. You get C6.
That's not X.
That's not hex.
No, it can only be 2.
What's the question?
You said what happens if you
Yeah,
put
like
3
add
letters
another-
instead of 2?
Oh, 3 letters?
Yeah.
You technically can't. But you can, but you can't do it with this calculator. You have to do it manually. That's part of the part that won't work. When we get to the Gloyes field, you see it won't work. So at that point, you'll have to use manual ways. So we have to, what happens is, if you use numbers that are too big, it actually does create a third hexadecimal position. We can't do it with our calculator. And even if you do, it's going to give you the wrong result. So in that case, what we do is we XOR with the Gloyes field, and then we'll get there. Is everybody okay on this new state, how to do it? Pretty simple. It's literally straightforward, XORing across. Know how to do it. It's not hard.
Just XOR every block with this.
Right, top left, so it'll be 16 with 4A gives us 5C.
and it's the same thing if we use the chart, if we do it manually.
Yes.
I hope nobody mess up. No,
There's a lot of stuff in there. Okay, so we got that.
Don't you at least walk us through? Don't you at least walk us through each of the steps? I believe, kind of like last time.
Oh, we're gonna do that when we get to the matrix. We'll go through all when we get to the matrix.
No, like you give us the you at least give us the proper starting numbers.
Oh, yeah.
You don't expect.
In
us
this
to work
stage,
all-
I will give you state and I'll give you the cipher key.
And you have
So I give you the 2 left blocks, you have to create the 3rd block.
So this is part 3. No, this is part 2. We're still in part 2, right?
1 or 2,
Okay.
I don't know. Part 1 was ASCII to hex. Part 2 was create round key. Part 3 is new state.
Okay, so yeah.
Alright, now we're going to sub the bytes here. This one, so can you possibly guess what will happen?
You have to
So if I take B2, what should I do, what you think?
find on the table.
Find it on the table, so let's look. B2 through that table becomes that. So B2, so if I take first number B, 2,
B,
2, I'm sorry, 2,
I think that's 37.
37. You agree, Taylor, is that 37?
I'm going with that.
Can everybody see that?
It's either 37 or 7.
It's 37. Let's do B8. B8,
6.
it's over here somewhere. B8, 6C. Okay?
So
Good.
we have to do it
Hope you don't
again.
have larger chart.
What?
So we have to look at the chart again.
Yes.
And
Chart.
Now, for the homework, you'll see the first couple, there's actually a picture of everything you need. I didn't do it for all of them. So, for the homework, you might have to refer to a couple of these charts in the practice, but print out the practice one. It's got all the charts in it.
Okay.
Now I even have a special chart for you. Okay, now we're gonna do shift rows. Okay. Take the first row, no shift. Second row, watch what happens to you. You ready? The 22 went over to the right. So basically it rotated that way. Okay, let's go back. So watch, the 49 is going to be the leftmost number. So it's going to be 49, 12, 56, 22. So what do you think the next one's going to be?
3F, 7B.
3C.
Okay, so we shift by 2. So you think 3F, 7B, 3C, 61. So what do you think the last one's going to be?
6C, FA.
It'll be 6C first, AF 27B. I see that? Easy enough? I guess it would have been handy if we had left them on the left side as well. If someone wants to edit the PowerPoint so it keeps it on the left side and copies it, that'd be awesome. Might not be worth any extra credit. Okay, now comes the tough one. Now with this one, I'm going to show you something here. If we look at our course page, there's a page called, right here, AES Worksheet Matrix Instructions. I tell you, in here, okay, I label them all. So A times 1, XOR B times 2, XOR with C times 3, XOR with D times 4. All those things give us AA. So I got this chart for you. This will tell you how to do every one, so you can, because when we walk through this, you're going to be like, what? What went where? Okay.
So the first column you use the top, then.
Right. The first column, top row, gives you the top.
And the second column uses the next column.
Yes. Okay. So let's walk through this. This is called mixed columns. We take the left column times the top row. Then we take, the left column times the top row gives us the AA, the top corner.
Okay.
The left column, second row gives us the second number on the top row. Left column, third row gives us the third number. Let's look back at the sheet again. So EE right here is actually, darn, I was wrong again. No, they go this way. I keep mixing up which one goes where. So left column, top row gives us AA. Left column, second row gives us BB. Left column, third row gives us CC. Left column, fourth row gives us DD. See that? That's the way it goes. Sorry, I don't do this enough to remember. Find it yet, Roy? So, everybody okay on that? So, the second column, top row will give us EE. Second column, second row will give us FF. See, it tells us right here. And second column, so on and so forth. Okay? So, back to here. So we did the left column, top row, left column, second row, so on and so forth. And we're going to see the math behind it in a minute. And we do the second column, top row, second row, third row, fourth row. And we do the third column, top row, first row, second row, so on and so forth. Now what happens, see in there we have a lot of ones. We don't have to do much with those, which is kind of nice, which we're going to show you in a minute. Fourth column, same thing. All that math just to get the new section. Okay. Now let's see how it actually works. Well, with matrix multiplication, you need this little chart. You need to write out 1 through 8. Okay. Now, if we have 37, remember that's the number that was on the left column. 37 times 2 is what we're going to do first. Then we're going to do 37 times 3, then 37 times 1. Okay? Yeah. Okay, well, let's do 37 first. 37 times 2, then 49 times 3, then 3f times 1, 60 times 1. All that's going to give us what? Does anyone remember? That'll give us the AA, that first block. So 37, there's 3 and 7. So far so good? And there's 2. But this way here, what you need to do is you need to convert them into an algebraic expression. It's actually very simple. So if we look at 37, see how 37 in binary is 0011, 0111. So starting from the right, we're going to end up with a 1, a 1, a 1, 0, 1, 1, 0, 0. Do you agree with that? Everybody see that? So the x to the 5th is because we have 1 here. We have an x to the 4th. We do not have any x to the 3rds, but we got an x to the 2, an x, and a 1. Everybody see that now?
So anything with a 0 we don't use.
Right, we don't use. We only bring down the ones that have 1s. And don't worry about the 8th bit. You probably don't need. Well, you technically might, but we'll see. At least in this case, we don't need it. Okay. So a 2 is just x. Why is 2 equal to just x? Right, it's all zeros over here. Then it's 0, 0, 1, 0.
Can you please start like from the?
Start at the beginning again?
Because I'm
Okay. Okay, let's take the 30. Let's go back to. Okay, so let's start this part. So remember that first column over here, we had a 37.
Yes.
So we have 37 times 2. See that?
Yeah, I see that.
Okay, 37 times 2. So let's walk through 37 times 2. So we're going to do 37 times 2, then we're going to do the other ones. Okay, so far?
Yeah, I get this part. I don't get the part when.
Okay, so let's take 37.
Okay.
Now I'm going to bring up handy dandy pen right here. So 37 is equal to 0, 0, 1, 1, 0, 1, 1, 1. Y'all agree?
Okay. Cool.
So what values for x do we have right now?
5x, 4x.
We have x to the 5th, x to the 4th, x squared, x, and 1.
Okay.
You see that?
Mm-hmm.
Okay. So that is what we get for the first part. So 37 becomes x to the 5th. What?
Why does it say x instead of 2? Because you're adding 2 to the power of 5 plus 2 to the power of 4.
Don't worry, we're not adding nothing yet. We literally haven't added anything yet.
Plus is important.
Don't worry, we'll get there. Because we have this and this. We're not adding them together. Trust me, we're not. We're not adding them together. Just watch. Okay? So a 2 is 0, 0, 0, 0, 0, 0, 1, 0. Do you agree with that one?
Okay.
So that would be what? Just x.
Yeah, which is okay. Yes.
Okay.
So just x.
Okay.
So if I had a blue pen here, is there a way to erase this? Erase all ink on slide. Oh, there is. Let's do the 2. We'll do the 2 in blue. So if we do 0, 0, 0, 0, 0, 0, 1, 0. You're just converting it to binary, and whatever digit it is, you go with that. Everybody see that? Okay. So let me clear this one out. So now we have to multiply them. Now, what do you think happens when we take x to the 5th and multiply it times x? So x to the 5th becomes x to the 6th.
Yeah.
X to the 4th becomes x to the 5th. What happens to x squared?
Third.
X to the 3rd. How about x?
Square.
X squared. And how about 1 times x? X. So then we take this number, this new number we have here. If I can find where'd my pen go? There it is. There it is. So now we'll do this one in green. So now we have no 7s, but we have a 6, we have a 5, You don't have a 4. You have a 3. You have a 2. We have an X. We have a 0. Everybody see that?
We found it.
Where was it?
Oh, it's missing. It's gone.
Oh, you found who took it? Was it cleaning crew?
Nope.
Who was it?
Somebody that just walked in. Right in the middle of dead everyone too.
Was it in the middle of the day?
Stephanie was here. It was just a little bit after morning. It's gone.
What, today?
Yeah.
Then
Then you need to get with security. You need to get with security, and they can show them their picture.
okay.
Wait,
Wow.
He spent like 45 minutes convincing himself it was you and it was a joke.
No, I told him I didn't do it. I wouldn't hold the joke that long.
What was it?
PS4 and all of his games.
And a couple.
Part of the Wii stuff, the Wii U.
All of the.
What?
Xbox
I imagine it has to be a student.
It has to be. Unless it was one of the cleaning crews said, hey, go in that building.
Why he steal the PS4 though?
But we have cameras with all his face on it.
Yeah, that's the weird thing is that they still.
Okay, let's continue on. Those who listen to the recording, we just had a theft, and that's what it's all about. Okay.
I just want to ask
Broad day.
why the PS4? Why not the Mac?
Okay, let's watch. You ready?
It's easy to carry it out.
All right. So we converted it to binary, and that binary becomes 6E. Okay? Everybody good with that? Then we do 49 and 3. You okay with this one? There's 49. There's a 3. So how do they work? So x to the 6th becomes x to the 7th. X to the 3rd becomes x to the 4th. 1 becomes x plus x to the 6th, x to the 3rd, and 1. See, because we got a 1 in there. We have to multiply each of them by the x and then the 1.
Just like that.
Exactly. So you do that, then you end up with, whatever that value turns out to be. Then you add them up. You can reorder them, no problem. And it becomes that, and it becomes dB. Okay? All right. Now we do 3F. So 3F and O1. Let's walk through this one. So 3F is x to the 5th, x to the 4th, x to the 3rd, x squared, x and 1. Times 1 is the same. So 3F times 1 is 3F. So don't bother doing the math. So what do you think 6C times 1 is? 6C. Then you take those numbers we just made, which were all there, and you add them all, an x for each one, and you end up with, come on, that times that gives us those numbers there. And you XOR each of them together. You're still good with the calculator at this point. And you get, somehow the equal sign moved into the wrong place, but you end up with E6. I don't know why that did. That's weird. Okay. So everybody okay on how to do that? So what will we do to get the second number?
Multiply all of that by the second row.
By the second row. So 37 times 01, 49 times 02, 3F times 03, and 6C times 01, correct? Okay. That's going to give us all of them. We're not walking through each one. But there's going to be some times where you have issues. Sometimes the numbers are going to be too big. So let's talk about those. There's something called the Gloyes field. So if I have an E7, let's watch through this example. So if I have E7 and a 3. Okay. So there's E7 and there's 3. Okay with that? So we're going to multiply them together. So we multiply 7, x at 7, 6, 5, 2, x and 1 times x times x, and we get that. Plus that times that, we get it all again. Now you'll notice we have some duplicate values here. You see that? With duplicate values, you cancel them out. So you get rid of the x to the 7s. You get rid of the x to the 6s and the x squareds and the x. Okay? You basically wipe out duplicate values. So what do
Today,
we,
this morning.
hold on, wait a second.
Well, I'm gonna run over to security. You can refill. It was
Okay, see, it wasn't me. Okay, so what are we left here?
As soon as they get it back, take it again.
Okay, so we're left with x to the 8th, x to the 5th, x to the 3rd, and 1. Now, does anyone remember when we first started doing this matrix, and I had those x's at the top? It was 1, then x, and x squared, x3, x4. Remember that? And we went up to x to the 7th. Okay, fine. Hold on. I'll go back 18 slides. Remember that? See, our biggest number is x to the 7th. We can't do anything beyond that. So now when I go all 85 slides forward here, okay, so we now have an x to the 8th. It's too big. Whenever you have a number like x to the 8th, you can't use it because remember our chart only went up to x to the 7th. So what we do at that point, we XOR it with the glorious field from the top of the slide. Okay? So we convert x to the 8th, convert each of them to binary, we XOR them together. And since the glorious field also has a 1 in that position, it basically gets rid of it.
You'll never get it back.
Now what you could do, which I'm not going to do for you, you could actually figure out in hex what the glorious field is and XOR your result with that, and it'll solve your problem. But you're going to have to do a little bit of looking at this. It only happens, I think, when you have a 3 and a larger number on the left. But so we get that, and then that number can convert it back to 32.
I'm just kidding.
So everybody okay with that? Walk through the example. At least the multiplication. At least matrix multiplication. Okay? All right, so once we get that, then we take the initial round. Again, I give you the 2 numbers. You have to calculate the 3rd one. There it is. I don't know why that's typed. There's the state after the mixed columns. There's our round key, which we brought down. Again, when you do this, I will be giving you the values. So don't use the round key you created or anything like that, okay? Then you XOR those, and that's just one for one. Pretty simple there. That's all there is for AES. It's only this middle section that's tough.
There's just gonna be one problem.
Okay, I'm going to hold on. Let me get out of here. Discard annotations. I'm going to open this up. Okay, so go get this here. I'm going to let you see what the questions, so you know what you have on the homework assignment. You have 1 from each section. So there's 1 out of 10, 1 out of 4, 1 out of 7, 1 out of 4, 1 out of 4, 1 out of 4, and 1 out of 4. So though you basically have 7 parts to this homework assignment. Okay. Now again, I only did practice off this first one because it's the only one I had more than 7 of. See here, I only have 4. This one I have 7. This one I have 4. So. Okay, make sense? And let me freeze this real quick. Okay, let me pause. Okay, so to reiterate that, the final test question about AES is this one. It's not this one, but it's this step. State 4 is the very last step from AES, is the one that's on the test. Okay? That help?
At least we can practice.
All right, I'm going to stop the recording.